Hi everyone, this is Dr. Nak. We are going to go over section 7.4. The title is trig function of any angle. So any angle means not necessarily an acute angle. Acute meaning between 0 and 90 degrees. It can be bigger. All right, so let's first go with the definition. Let's read this together. Let theta be any angle in standard position, and let ordered pair a comma b denote the coordinates of any point except at the origin on the terminal side of theta. If r equals square root of a squared plus b squared is the distance from the origin to the point a comma b, then the six trig function of theta are defined as the ratios, where sine of theta is b over r, blah, blah, blah. So let me just draw you a picture and see what they're talking about. So let me just draw, maybe I could squeeze it in here. Okay, so let's just call this x-axis, that's a y-axis. Now, let me change the color to do the initial side. Suppose this is our initial side. And let's make this not an acute angle, so let's make this is the terminal side. Okay, so any point on the terminal side, I'm just going to plot it as right here maybe. And this point is a comma b that they're talking about. And then distance from here to here is r. Okay, so this is the situation. Oh, sorry, let me just write this is 0, 0. And our theta is always from the initial side to the terminal side. So this is our theta. Okay, so now maybe this will make sense. All right, so if this is the situation, then sine of theta is b over r. Cosine is a over r. Tangent is sine over cosine, so it's b over a. Cosecant is 1 over sine, r over b. Secant is 1 over cosine, so it's r over a. Cotangent is 1 over tangent, so we're going to have a over b. Okay, so now since we're talking about any angle in this section, what I've done is I've drawn the quadrant 1, quadrant 2, 3, and a 4. Now notice that quadrant 1, x and y values are both positive. In quadrant 2, x is negative, y is positive. In quadrant 3, x is negative and y is also negative. And quadrant 4, in this case, x is positive and y is negative. So keep that in mind. And let's draw out 4 different cases where the theta is going to lie. All right, so suppose our initial side, I'm just going to make our initial side. Let me see if this tool works like this. Uh-oh, can you see this all right? Oh my goodness. Oh no, the axis is moving now. All right, so hold on 1 second. Let me just redo this again. So what I wanted to do is this is going to be our initial side. Hopefully you can see this. All right, and then suppose our terminal side lies in quadrant 1. All right, so okay. So if this is the case, our theta that we're talking about will be, let me see, let me just change the color. This is our theta, where theta is in quadrant 1. Okay, so in this case, any point that you're gonna pick along the terminal side, if I call this a comma b, notice that a is positive and also b must be positive. So let me just draw it out and what's going on here. So if this is the case, distance from here to here is b, and then from to here is r, and from here to here is a. Okay, now the second case is if the theta lies in quadrant 2. So let me just draw that out. I'm just going to put an arrow right there. So let's pick any point. So let's just call this point. And I'm just going to jot this down and form a 90-degree angle here. Now, notice that in quadrant 2, x value is going to be negative. So maybe this is negative a. And the y value is positive. So from to here is b. And again, your r is always going to be positive. So in this case, this point right here is denoted by x is negative a, and then y value is b. And so we're talking about the angle theta, which lies in quadrant 2, can be denoted as negative a, comma, b. Now case 3 would be if the angle theta lies in quadrant 3. Okay, so let me change the color again. Oh my goodness, I'm going to run out of color pretty soon here. All right, so from here to here is our theta now. I hope you can see this color. So now I'm going to pick a point here. Now, if I draw the same vertical line and then make that into a 90-degree angle, notice that your x value is going to be negative, and then y value is also going to be negative. So from here to here will be negative b. So this point right here can be represented as negative a, comma, and then negative b. All right, so that was case 3. And case 4, if your theta lies in quadrant 4. I don't like that line. Let me just erase that and then redo it again so that I can draw a better picture. Okay, so I should draw this out from the very beginning. Sorry about that, guys. All right, so now let's take a look at this case. Now I'm completely running out of colors, so I'm just gonna draw this in red again. So our theta now becomes from the initial side and then going around and to the terminal side. So this is gonna be our big old theta. All right, so let's pick a point. Now in quadrant 4, x value is positive and y value is negative. So from here to here is going to be what? Negative b. And of course from here to here is r. All right, so this point right here, in terms of a's and b's, I can describe this as a, comma, negative b. All right, so sine is again b over r, and cosine is a over r. Keep that in mind. Okay, so let's do some examples now. So example 1, find the exact values of 6 trig function of a positive angle theta if 5, negative 12 is a point on the terminal side. So I always like to draw the picture and see what's going on. So let me just draw the picture and out here. Okay, so let's call this x-axis and then y-axis. And 5, negative 12. So x is 5. So this is going to be completely drawn off the scale, but all right, so from here to here is 5. And then y is negative 12. So let's pretend this is negative 12. Oh my gosh, pretend that's straight. So meaning from here to here is negative 12. And the terminal side. So let me just draw the initial side and terminal side in different color. So this is our initial side. And then our terminal side is going to be right here. I love this future. I could draw a perfectly straight line. All right, but anyway, so this point right here is 5, negative 12. And our theta that we're talking about is this ginormous angle from initial side to the terminal side. So what we want is we want to find the exact value of 6 trig function of that angle theta. Okay. Now notice that if I write it in terms of 5 comma negative 12, 5 is your A, and then B is going to be negative 12. Okay, now let's find the value of R. Okay, so since we have A equals to 5 and then B equals to negative 12, our R is going to be square root of A squared plus B squared, which is square root of 5 squared plus negative 12 squared. So what the heck is that? So that's going to be what? Square root of 25 plus 144 is 169. So looks like this is going to be 13. So our R is 13. Okay, so I think we are ready to do this. So therefore, remember that triangle means therefore. I'll write every step out here. So sine of theta is B over R, which is negative 12 over 13. Cosine of theta is A over R, which is 5 over 13. And then tangent is sine over cosine. So you don't really have to memorize in terms of A's and B's and C's as long as you found out what the sine and cosine is. But let me just write everything out. It's B over A, which is negative 12 over 5. And then let's go with the cosecant is what? 1 over sine. But let me just write every step. So this is going to be negative 13 over 12. And then secant is 1 over cosine. So it's 13 over 5. And cotangent is 1 over tangent, which is negative 5 over 12. So that is, whole thing is going to be our answer. Let's do another example. Example 2, find the exact values of the 6 trig function of the quadrantal angle theta equals 3 pi over 2. Remember that quadrantal angle means that your theta is going to lie on the x-axis or the y-axis. Okay, so let's just draw out the picture and see what's going on. I'm going to draw the initial side. I hope you can see this. So here's my initial side. And then let's measure 3 pi over 2. 3 pi over 2, if you still haven't memorized it yet, okay, so we could, if you're more comfortable in terms of degrees, when theta is 3 pi over 2, that's same thing as what? 3 times 180 divided by 2, so which is 270 degrees. Okay, so 270 degrees will be over here. So this is going to be our terminal side. So our angle theta, so this is our theta equals to 3 pi over 2. Now, unlike the example 1, do you see that I can pick any point that would lie on the terminal side, because no matter which point I pick, and the axis will not change the angle. So I'm just going to pick some random point and I'm going to make my life really, really easy. So here, maybe I can describe this point as maybe when x is 0 and then y can be negative 1. I'm just going to randomly pick any point. You can pick any point that's going to make sense, that which lies on the bottom, the y-axis. All right. So if I chose it in this way, our A is 0 and then B is going to be negative 1. Okay, so let me just write everything out. A is 0, B is -1. So let's find R. R is the square root of a squared plus b squared, which is going to be 0 squared plus -1 squared. So that's what? 1. So in this case, what do we got? We got R equals to 1. Okay, so let me just box this. And we got our A's and B's and R's. So we're ready to go. All right, so that said, I hope I have enough room to answer this. So sine of theta, theta is 3 pi over 2. Sine is b over r. So this is -1. And then cosine of 3 pi over 2 is a over r. So you got 0 over 1, which is just 0. And the rest of it, we got sines and cosines, so we're good to go. So we got tangent of 3 pi over 2, which is, tangent is what, b over a. So it's 1 over 0. Uh-oh. 1 over 0 means what? Undefined. So tangent of 3 pi over 2 is undefined. I'm just going to write it as undefined. Okay, now cosecant of 3 pi over 2 is r over b. Well, still going to be -1. And then secant 3 pi over 2 is r over a. In this case, 1 over 0, so it's going to be undefined. And then what else do we have left here? Cotangent. And 3 pi over 2 is a over b, which is 0 over 1, so it's going to be 0. And there you have it. Okay, so in summary, when theta is 0, pi over 2, pi, 3 pi over 2, so those are all the quadrantal angles. I already wrote out the values for sine and cosine. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, and sine of 3 pi over 2 is -1. You can derive that by the way we just did in the previous examples. And cosine of 0 is 1, and cosine of pi over 2 is 0, cosine of pi is -1, and then cosine of 3 pi over 2 is 0. All right, so then since we got sines and cosines, you should be able to derive the rest of the other trig functions. Okay, so now let's go with the new definition. So the definition is two angles in standard positions are coterminal if they have the same terminal side. So I'm drawing you two pictures there. So let's look at the first picture, alpha and beta. Alpha and beta are coterminal because they both better start out from the same initial side. And notice that, remember, you can revolve positive side of the angle counterclockwise, and negative side will be clockwise. So in this case, alpha is positive, beta is negative, but regardless of which picture that you're looking at, they end at the same exact terminal side. So we say that in this case, alpha and beta are coterminal. Okay, let's just go ahead and get into some examples. So I'm going to call this example 3. Use a coterminal angle to find the exact value of each expression. So we're going to do a few examples here so that we'll get better understanding of what the heck is going on. All right, so first example A, let's use the coterminal angle to find sine of 390 degrees. Again, it always helps me when I can draw out the picture. So let me draw that out real quick and see what's going on. All right, so 390 degrees is what? You're going to have to revolve 360, which is 1 revolution. And then how much further do we need to go to get to 390? So that's basically what? 390 minus 360, which will be 30 degrees. So we're going to have to revolve 30 degrees more. I hope you can see what I'm doing here. But regardless, our terminal side is going to be here. All right, so here in red, I'm just going to write it as 390 degrees. And the coterminal side will be 30 degrees. Okay, so if I have to show all of my work, notice that then sine of 390 is same thing as sine of 360 plus the 30 degrees. Okay, but oops, that's going to be same thing as sine of 30 degrees, which is 1/2. So sine of 390 degrees is exactly going to give us the same value as sine of 30 degrees, and which is going to be 1/2. Okay, so let's do another example. So let's call this one example B. Let's go with secant of 540 degrees. All right, so again, I'm going to draw out the picture and see what's going on here. Okay, so let's first determine how much revolution that we're going to have to go. All right, so 540, we definitely have to revolve whole entire 360 first. And then how much more do we need to go to get 540? So you could go 540 minus 360 to get the remaining angle, which will be 180. So we're gonna have to, from here to here, we're gonna have to revolve 180 degrees. So our terminal side is gonna lie on the negative x-axis. Okay, so let me just write this guy as 540 degrees. Now the coterminal side, let me just draw that in different color. Coterminal side will be from here to here, which will be 180 degrees. So basically secant of 540 degrees is going to give us the same value as secant of 180 degrees. But if I have to write every step out, so this is secant of 360 plus 180, that's a plus, which is going to give us the same value as secant of 180 degrees. Now secant is 1 over cosine. Okay, so 180 degrees is same thing as pi in radian measure. So I already drew the chart above just to save our little time here. So cosine of 180 degrees is -1. So you're going to have 1 over -1. So our answer is going to be -1. Before I do the next example, we're gonna have to learn this anyway. So do you see from example A, I broke down the 390 into 360 plus 30, and also the sine of 390 degrees is same thing as sine of 30 degrees. Now that 30 degrees is gonna be called the reference angle. And also for the for example B, 540, we broke down to what? 360 plus 180. And so therefore 180 degree part is also called a reference angle. But anyways, let's go with the next example, which is going to be, let's call this one C. All right, so let's do something a little bit more involved. How about cosine of 33 pi over 4? Boom. All right. So now, if you're not comfortable with the radian measure, you can convert this back into a degree measure. So let me change the color here. So note that 33 pi over 4 isn't that same thing as 33 times pi over 4? But pi over 4 is 45 degrees, so 33 times 45 degrees. What is that? 33 times 45, 1,485 degrees. Dang, that's a big old angle that we're talking about. Now, if you want to know how many times it's going to revolve around, you can easily start subtracting this huge number by 360 just to see how many times the 360 is going to go in. So if I subtract 360 from this, what do we get? 1125, still going to be bigger than 360. So now let's subtract another 360 from this. So this means we already revolved once. This is going to be revolving twice. So then here you're going to have 765 degrees. All right, we could still revolve around it. So you're going to have, let's go with minus 360 again. So in this case, we get 4 or 5. Dang, we could keep revolving around and around and around. All right, so we could go one more time. So if I subtract 360 from this, oh, look at it. Finally, 45 degrees. Okay, so it looks like we're going to have to revolve 4 revolutions and go up 45 degrees more. All right, so let me just draw that out. Okay, we got this. Easy peasy. All right, ready? 1 revolution, 2, 3, oh my gosh, and oh my goodness, look at that circle, 4, my eyes hurt, and then you're gonna go 45 degrees more. All right, so it looks like our terminal side is right here. Oh my gosh, so in red color is our 33 pi over 4. Okay, now the coterminal side can be measured from the initial side to the terminal side, which will be just 45 degrees, which is just a pi over 4. Okay, so let me just write everything out. So it looks like its reference angle is going to be pi over 4. So basically, cosine of 33 pi over 4 is going to be the same thing as cosine of pi over 4. That's pretty much how it's going to be. But if I have to spell this out in step by step how the textbook does it, so you can rewrite 33 pi over 4 as pi over 4 plus, what can I add to make that 33 pi over 4? 8 pi. You don't have to show this work, but I'm just doing this the proper way, which is same thing as cosine of pi over 4. Yeah, feel free to skip this step. I mean this step right here if you don't like it. All right, and then cosine of pi over 4 is square root of 2 over 2. So that's going to be the answer. What the heck, let's do another one. Okay, so let's call this one example D. We did sine, secant, cosine. How about cotangent? All right, cotangent of, we haven't done negative angle, so let's go with negative 7 pi over 4. All right, we got this. So again, if you're not familiar with the radian measure, convert that into degrees, until you get used to it. So let me just change the color, and as a side work, let's go with negative 7 pi over 4. That's same thing as negative 7 times pi over 4. Again, pi over 4 is how many degrees? 45. So if I multiply that, I'm going to have negative 315 degrees. All right, so keep that in mind. Okay, so if I'm going to draw this out, let me see, I'll just draw it on this side again. Now remember, we're given the negative angle, so we're going to have to revolve clockwise from the initial side. Okay, so always, initial side is always going to start from the positive x-axis. Now, negative 315. So where would that be? Okay, so definitely we're gonna have to go negative 180, negative 270. And from negative 270 plus what's gonna give us negative 315? That will be what? Another negative 45 degrees. All right, so it looks like our terminal side is going to be here. All right, so this big old angle going clockwise is negative 7 pi over 4. Now the coterminal side, it's going to be what? 45 degrees, so which is going to be pi over 4. So guess what? Cotangent of negative 7 pi over 4 is going to be the same thing as cotangent of pi over 4. Okay, but if you want to follow the textbook way, so you don't have to do this step if you don't like it. So if I have to rewrite cotangent of negative 7 pi over 4, so this is going to be what? Cotangent of pi over 4 plus, but this is going to be what? We're going to revolve towards a negative angle, so this is going to be what? Minus, what is that, 2 pi? It's going to give us negative 7 pi over 4. Well, either way, our answer is going to be same thing as cotangent of pi over 4. Okay, so that's same thing as cosine of pi over 4 over sine of pi over 4. Okay, so which is root 2 over 2 over root 2 over 2. So our answer is 1. If I had sine of, let's look at example A, sine of 390 was what? Sine of 360 plus 30. So our 30 is the theta, and 2 pi times 1 would be, that's 360 part. Okay, so in summary, from the previous example that we did, the value of a trig function of any angle is going to be the value of a same trig function of an angle theta that's going to be coterminal to the given angle that's going to be between 0 degrees to 360 degrees. So to write that out mathematically, that's boxed in red right below. So sine of theta plus 2 pi k is sine of theta. Now 2 pi k, 2 pi is 360 degrees. So basically, so if you had, let's go back to the previous example there. So does that make sense? So sine of theta plus 2 pi k is any integer. In this case, k was 1, and for example A, that's going to equal to sine of 30 degrees, which would be just sine of theta. And cosine of theta plus 2 pi times k is cosine of theta, and so forth. All right, and 2 pi is 360 degrees. What do I have over here? Let me just erase this. All right. So notice that the value of the trig function repeats every 360 degrees, which is 2 pi radian. All right, so now another things that you're going to have to memorize now is the positive quadrant, sign of the trig function of the angle in given quadrant. All right, so a lot of students memorize this as all students take calculus. So all is in quadrant 1, means all positive. So meaning all 6 trig functions are going to be positive in that quadrant 1. Now in quadrant 2 is denoted by student. So S stands for the sine, and 1 over sine is cosecant. So in this case, what's positive in quadrant 2 is sine and its reciprocal, which is cosecant, are positive in quadrant 2. Now in quadrant 3, all students take calculus. So T stands for tangent. So tangent and 1 over tangent, which is cotangent, positive in quadrant 3. And quadrant 4, stands for calculus, meaning C stands for cosine. So cosine and its reciprocal 1 over cosine, which is secant, are all positive in quadrant 4. Because let's go back here. Look at the positive quadrant. For the sine is going to be positive in only quadrant 1 and quadrant 2. So in that case, you just take the positive side of it. And then for the sine's negative in quadrant 3 and quadrant 4. So in that case, you just take the negative side of the sine. All right, so here comes that word, reference angle. Definition: let theta equals the angle that lies in a quadrant. The acute angle formed by the terminal side of theta and the x-axis is called the reference angle for theta. I think the best way to do this is by examples. So let's just go ahead and start doing some examples of it. So find a reference angle for 210 degrees. So always draw out the picture and see what's going on. So basically what we're going to do is we're going to find out where the 210 degrees is going to lie. Okay, so here's the initial side. And 210 degrees is going to be what? Revolving 180 and then what? Adding 30. So this is going to be the terminal side. So I should have wrote this already. And then here to here is 30 degrees. All right, so the reference angle for 210 degrees is 30 degrees. And that's our answer, because all we want to do is find the reference angle. All right, so let's do another one. Part B. How about 5 pi over 6? Okay, so again, if you're not comfortable with the radian measure, convert that into a degree measure if you like. Now, pi over 6 is what? 30 degrees? But either way, my goodness. So this is the initial side. 5 pi over 6 is going to be maybe over here. And then when I add these two angles, it better add up to pi, right? Which is 180 degrees. So from here to here would be what? Just 30 degrees, which will be just pi over 6. So its reference angle for 5 pi over 6 is just pi over 6. Oh, that's a 6. Oh my gosh. Oh my goodness. Okay, so notice that if you're given 5 pi over 6, your reference angle is going to be pi over 6. So guess what? If you're given 5 pi over 4, your reference angle is always going to be pi over 4. If you're given 5 pi over 3, your reference angle is going to be pi over 3. I just thought I'll just throw that in there just to save you some time. All right, now let's do another one. So let's call this one example C. Let's go with negative 135 degrees. All right, so drawing out the picture. Oh my gosh, I need to learn how to draw a straight line. All right, so here's the initial side. Now we're going to revolve towards a negative angle. So negative 135 would be maybe over here. Okay, so negative 135 plus what is going to give me negative 180? That will be what? 45 degrees. So angle from here to here is going to be, we could say negative 45 degrees if you like, or just simply 45 degrees will be okay. All right, so coterminal, not the coterminal, reference angle for negative 135 degrees is negative 45 degrees, or just simply 45 degrees. Okay, so now here comes the big theorem, reference angle theorem. This is a very useful theorem. So let's see. It says that if theta is an angle that lies in a quadrant and theta is its reference angle, then alpha is its reference angle, then sine of theta is going to be either plus or minus sine of alpha. Cosine of theta is going to be plus or minus cosine alpha. Now the plus and minus is determined by which quadrant your theta is going to lie in. Don't worry, we'll do some examples in a minute. Okay, example time. All right, so let's call this one example 5. Use the reference angle to find the exact value. All right, so the first one, let's go with cosecant of 300 degrees. So step number 1, always draw that picture out. Okay, so let me just draw where the 300 degrees is going to lie in. Okay, so before I forget, let's write down the positive quadrant. All student take calculus. Okay, so now let's go with the, what is that, 300 degrees. So 300 degrees is going to be what? It's going to lie in quadrant 4, it looks like. So initial side, terminal side, oops. So this is going to be 300 degrees. Now what is its reference angle? Reference angle here is 60 degrees. Okay, now let me just spell everything out here. So theta is in quadrant 4. So in that case, who's positive in quadrant 4? Cosine and 1 over cosine. So those are the only guys that's going to be positive. So in this case, cosecant is going to be negative in quadrant 4. Okay, so that means cosecant of theta is negative. So according to the reference angle theorem, it says that this is going to equal to negative cosecant of the reference angle for 300 degrees, which is going to be 60 degrees. All right, which is negative 1 over sine of 60 degrees. 60 degrees is pi over 3, so negative 1 over root 3 over 2. So you're going to have negative 2 over root 3. Rationalize the denominator, and we're going to get negative 2 root 3 all over 3. And that's going to be the answer. I'm going to do a few examples of this till we get a hang of it. All right, so let's go with B. Let's go with cosine of 2 pi over 3. Okay, so again, first step, determine where that angle is going to lie in which quadrant. So I'm going to do the same thing. All students take calculus. All right, so 2 pi over 3 is going to lie in where? Quadrant 2. Again, if you're not comfortable, pi over 3 is 60 degrees. So 60 degrees times 2, that should lie in quadrant 2. So let me go with terminal side. Initial side and a terminal side. And from here to here, our angle is 2 pi over 3. As I mentioned before, if it's 2 pi over 3, then its reference angle is always going to be pi over 3. Good to know, right? So from here to here is going to be pi over 3. Now, let's determine whether cosine is positive or negative in quadrant 2. Okay, so it looks like, let me see, theta is in quadrant 2. So cosine of theta is going to be what? Positive or negative? Negative, because only positive guys in quadrant 2 are sine and 1 over sine. Okay, so keep that in mind. So let's do this. So this is going to equal to negative cosine of, if its reference angle is pi over 3. So looks like it's going to be negative 1/2 is going to be our answer. Hope you're kind of getting hang of it. All right, so let's do another one. All right, so let's go with C. Let's do tangent. Tangent of 14 pi over 3. Look at it, it's 14 pi over 3, right? So you should guess the reference angle is going to be pi over 3. But still, you're still going to have to determine where the angle is going to lie in. So let's do this. Okay, so 14 pi over 3. So again, if you don't like radian measure, pi over 3 is 60. Multiply that by 14, then that's, I'll just write it out. Which is what, 840 degrees? So that should give you an idea of how much you need to revolve around. So let's subtract this guy by 360. That gives us 1 revolution. So that's 1 revolution, and it's 480. Now looks like we're gonna have to revolve again. Second revolution. If I go minus 360, that's gonna give us 120. So it looks like we're gonna have to revolve twice, then add 120 degrees on top of it. Okay, so but anyway, so let's just draw this out. So okay, 1 revolution, 2 revolution, and then 120 degrees will be, oh my goodness, it's like right here. So this is gonna be the initial side, and I'm gonna make this is my terminal side. So this is 14 pi over 3. The point is that that lies in quadrant 2. So, oops, I forgot to write my positive quadrant. All students take calculus. Okay, so again, its reference angle is going to be just pi over 3. Now, theta is in quadrant 2. So that means tangent is what? Tangent of theta is going to be negative. Okay, so this is the same thing as negative tan of pi over 3, which is same thing as negative sine pi over 3 over cosine pi over 3. So what is that? So that's going to give us negative root 3 over 2 over 1/2. So looks like answer is going to be negative root 3. Okay, so let's do another one. A, B, C, D, or D. Okay, so how about this one? Secant of, and let's go negative side. Negative 3 pi. Why in the heck not, right? Okay, so let's draw it out. Okay, let me change the color here. Initial side. And we're going to have to go negative 3 pi. So from here, this is negative 1 pi, negative 2 pi, and then negative 3 pi. So it looks like our terminal side is going to be the negative x-axis. So again, since this is going to be a quadrantal angle, you can pick any point on that axis and pick some easy number, like using 1 and 0. So in this case, it looks like what? X is negative, so let's call it negative 1, and then y is going to be 0. Okay, so this is going to be the value of A, and then this is your B. Okay, so in this case, remember, r is what? Square root of A squared plus B squared. Okay, so in this case, r is going to be square root of negative 1 squared plus 0 squared. So looks like r is going to be 1. So notice that secant is 1 over cosine. So let's just go with the, let's first find the cosine of theta is A over r, which in this case is what? A is negative 1, r is 1, so cosine of theta is negative 1. That's a 1, sorry. Okay, so keep that in mind. So let's tackle this problem. So this is same thing as 1 over, well, sorry, maybe I shouldn't have done that. Hold on, let's do the reference angle portion first. So this is going to be the same thing as secant of pi because from here to here is pi. All right, now this is same thing as what? 1 over cosine of pi. Now in this case, we're going to have 1 over -1. So our answer is -1. Hope that made sense. Okay, so let's do another quadrantal one then. So let's call this one A, B, C, D, E. All right, I have to sing every time. All right, E. So let's go with cotangent of 5 pi. All right, so let's draw it out. Where can I draw? All right, so initial side. Okay, ready? 1 pi, 2 pi, 3 pi, 4 pi. Wait, did I make that mistake here? Hold on. Let me just redo this. Okay, I can do this. Here is the initial side. Okay. Pi, 2 pi, 3 pi, 4 pi, 5 pi. All right, so again, it's going to lie on this axis right here. So this is going to be the terminal side. And we can pick the same point, maybe -1, 0. And so this is our A, and 0 is going to be our B, and R is going to be 1. All right, so reference angle for that will be pi again. So let's compute this. So cotangent of 5 pi is same thing as cotangent of pi. All right, now cotangent of theta was what? A over B, which is -1, and B is 0. So in this case, it's undefined. All right, so guess what? Cotangent of pi is going to be undefined. Okay, so I hope you kind of got a hang of this. Let me know if you have any questions. Okay, so let's do another example. Example 6. Find the exact value of the remaining trig functions of theta. All right, sine of theta is -2/3, and theta better be between 180 and 270 degrees. So I'm just going to draw this out. There are so many ways that you can do problems like this. But since we're using the reference angles in this section, let me just try to solve it by using the reference angle theorem. Okay, so let me see. So this is the initial side, and terminal side better be between 180 and 270, so it better be in quadrant 3. So let me just call this, oops, angle by theta, and I'm going to change the color for the reference angle. Reference angle, I'm going to call that alpha. So I'm going to say let alpha be the reference angle. All right, so let me just first draw the triangle and see what's going on here. All right, so sine is opposite over hypotenuse. So that's saying that opposite side, since sine of theta is -2/3, opposite side better have the length 2, and then the hypotenuse better have length 3. So when you look at the reference angle, that's telling you that opposite side of the angle alpha is 2, and the hypotenuse, opposite over hypotenuse, is 3. That's pretty much what's telling you. And of course, notice that your y value is going to be negative, but in order to view the triangle with the reference angle, the length cannot be negative, so that's why I have a 2 there instead of a -2. But anyways, let's determine the value of x. So we have what? Y squared plus 2 squared equals to what? 3 squared. I don't know why I put their y there, but anyway, so our y is going to be what? 9 minus 4, so square root of 5. I should have wrote it x. Sorry about that. But anyways, from here to here is square root of 5. Okay, so this point right here, in terms of x and a y, or a and b, this is what? When x is going to be negative, so it's going to be negative square root of 5, and then negative 2. So that's the point on the terminal side. Okay, but anyways, keep all that information in mind. So according to the reference angle theorem, they're telling you that sine of alpha is the reference angle, is the opposite over the hypotenuse of that triangle that I just drew. Forget about the minus part. You're just looking at the triangle of the length root 5, 2, and then the hypotenuse is 3. So since sine is opposite over hype, so you're going to have what? 2/3. Okay, and let me write down the positive quadrant. All students take calculus, and also notice that theta lies in quadrant 3. That means who's positive in there? Only tangent of theta and cotangent of theta are positive, and rest are all negative. So keep that in mind. Okay, so since the reference angle of sine of alpha is 2/3, so according to the reference angle theorem, that implies that sine of theta is going to be, so let's see, in quadrant 3, sine is negative. So here, you're going to have negative 2/3. But that's given to us anyways, right? But so let's just take a look at the cosine then. All right, now cosine of a reference angle, so reference angle means forget about the positive, negative side of anything. Just look at the triangle as is. Cosine is adjacent over the hypotenuse. So the adjacent side of that triangle is, square root of 5, and hypotenuse is 3. That's a 3. Okay, so maybe opposite over hype, adjacent over hype. Gosh, my writing is just getting worse and worse. Okay, so that implies that cosine of theta, now since cosine is going to be negative in quadrant 3, the answer is going to be negative square root of 5 over 3. All right, and let's go with the tangent. Well, we got the sine and cosine, so the rest should be okay. So if you have the sine and cosine of theta, you should be able to derive the rest of it. So you can compute the reference angle for tan of alpha, cotangent of alpha, and go with it. But since I've already determined the sine of theta and cosine of theta, I'm just going to use that to derive the other trig functions. So let me just box this, because this is all we need. All right, so with that said, tangent of theta is what? Sine over cosine. So the tangent in this case is going to be what? Positive 2 over square root of 5. Rationalize that. 2 root 5 over 5. And cotangent of theta is 1 over tan of theta. So here you're going to have root 5 over 2. All right, does it make sense? Sine is negative, cosine is negative in quadrant 3. Tangent and cotangent turn out to be positive. So we're good to go. And next one is what? We got tangent, cotangent, secant is 1 over cosine. So it looks like we're going to have negative 3 over root 5 rationalize that. Negative 3 root 5 over 5. And then cosecant is 1 over sine of theta. So here you're going to have negative 3 over 2, which makes sense because cosecant and secant should be negative in quadrant 3. So that's one way to do it. Now another way to do it is by using the fact that sine is what, b over r, and then cosine is a over r, and so forth, where this is going to play the role of a, this is negative 2 is going to play the role of b. That's another way that you can derive all 6 trig functions, but I'm just going to stick it with this way for now. We'll learn the other ways later on. Maybe that one was a little confusing, so let's just do another one. So let's just call this one b. So we're going to do the same thing, but let's go with cosecant of theta is 3. And then cotangent of theta is going to be negative. Okay, so first thing what we need to do is, where is our angle theta is going to lie in? Which quadrant? So let's figure that one out first. Okay, so I'm going to draw my picture as usual. Alright, so let's notice that cosecant of theta is positive 3, right? Oh, let me just write down. All student take calculus. Alright, so cosecant is positive in which quadrant? So theta better be in quadrant 1 because cosecant is positive. Everything is positive in quadrant 1. And then also cosecant of theta is positive in quadrant 2. Keep that in mind. Alright, and then cotangent of theta has to be negative. Alright, so which quadrant is that going to be in? So cotangent is negative in, where is it? The quadrant 2. And then quadrant 4. Okay, so where do they overlap? Okay, so cosecant has to be positive, cotangent is negative, so that means what? Theta better be in quadrant 2. Okay, so keep that in mind. So therefore, theta must be in quadrant 2. All right, so let's draw this out again. Initial side and terminal side. And from here to here is our theta. So the reference angle alpha is going to be right here. So let me just call that alpha. And I'm going to do the same thing as before. Let me just extend this so I could draw myself a triangle. Okay, so I'm just going to go draw the triangle like this. All right, so now let's use the fact that cosecant of theta is 3. All right, so cosecant is what? 1 over sine. So cosecant of theta is 3, means that its reference angle, cosecant of alpha, is going to be 3 over 1, which is same thing as hypotenuse over the opposite, because it's 1 over sine. Sine is opposite over hyp. Okay, keep that in mind. So that means that hypotenuse of that triangle better have length 3. Opposite side of alpha has length 1. Okay, so from here to here is 3. Opposite side of alpha, this is completely drawn off the scale, is 1. Okay, now we need to determine the value of the base, so let's call that the base to be a or something like that. So we know that a squared plus 1 squared better equal to 3 squared. So that means what? A better be the square root of 9 minus 1, which is square root of 8, which is 2 root 2. So length from here to here is 2 root 2. Okay. So if you want to, you can plot this point, the point on the terminal side. If you want to use, the A's and B's and R's, this point right here is nothing but what? What is the x value? X value is negative 2 root 2, and the y value is positive 1. So this is your A, this is your B, and then your R is going to be 3. So like I said, there are multiple ways that you can do this. But anyway, so let's at least compute the reference angle for the sine of alpha and then cosine of alpha. All right, so since cosecant of alpha is 3, sine of reference angle alpha is going to be 1 over cosecant, so it's going to be what? 1/3. Which makes sense because if you want to use A, B, and R, remember sine of alpha, I'll just write it down here. Sine of alpha was what? B over R, wasn't it? So that should make sense because our B is 1 and then our R is 3. All right, so that's for the reference angle. Now let's compute the sine of theta. Okay, so that implies that sine of theta is going to be, all right, so is sine positive in quadrant 2? Yes, it is. So you just keep it as positive 1/3. All right, now let's go with the cosine of the reference angle alpha. Now when you look at that triangle itself, cosine is adjacent over hypotenuse. Okay, so the adjacent side of the triangle has what? 2 root 2 adjacent over, 2 root 2, hello. And the hypotenuse is 3. So it should make sense because cosine of alpha is what? Was it A over R? So our A is, cosine of theta. I'm not the cosine about cosine of theta is A over R. So our answer should be what? Negative 2 root 2 over 3. Okay, so let's see if that's going to match up. But anyways, this implies that cosine of theta. Okay, now in quadrant 2, cosine is negative. So if you use the reference angle theorem, then cosine of theta is negative 2 root 2 over 3. Which matches up because look, cosine of theta should be A over R, not the cosine alpha. Cosine of theta should be A over R. So again, A is negative 2 root 2 and then R is 3, so which makes sense. All right, so your textbook computes all the reference angle for the rest of the trig functions, but we don't need to do that because we got ourselves sine and cosine of thetas. All right, so now let's derive the rest of it. So in this case, our tangent of theta is again sine over cosine. So we're gonna have 1/3 over negative 2 root 2 over 3. So what is that? 1 over 2 root 2. All right, let's just rationalize this denominator. Gonna have negative root 2 over 4. That looks like our answer. So I'm gonna box that. All right, now let's go with cotangent of theta. Cotangent is what? 1 over tangent. So in this case, what we're going to get is what? Negative 4 over square root of 2. Rationalize. All right, and then simplify. Then looks like our answer is going to be what? Negative 2 root 2. Okay, that's cotangent. Okay, so what do we got? Sine, cosine, tangent, cotangent. Now it's secant. All right, so secant of theta is 1 over cosine. So it looks like it's going to be negative 3 over 2 root 2. Dang it, we need to rationalize again. Okay, so what do we got? Negative 3 root 2 over 4. We got this. One more, just one more. Cosecant of theta is 1 over sine. So in this case, boom, no work necessary, just 3. And there you have it. All right, so you know what? Let's just do another one just so that we're comfortable with this types of problems. So let's go with C. Okay, so let's go with cotangent of theta is 4/3. And the cosine of theta is going to be negative. Okay. So again, first step is determine where the theta is going to lie in. All right, so which quadrant? So let me just write, all student take calculus. Okay, so let's analyze this. So we got cotangent of theta is positive 4/3. I'm just going to denote it as positive. So that means what? Cotangent is positive in quadrant 1. And where else? And quadrant 3. All right. And then let me see what else. Cosine of theta is negative. All right, so cosine's negative in which quadrant? Quadrant, so theta better be in quadrant 2, right? And then also in quadrant 3. So where do they overlap is quadrant 3, so therefore theta better be in quadrant 3. All right, keep that in mind. All right, so we got initial side and terminal side is in quadrant 3. So let me just write it like this. And this is our theta. Okay, so with that said, our reference angle alpha will be right here. That's our alpha. We're going to do the same business. Draw that right triangle. Okay, so first of all, cotangent of theta is 1 over tangent. So let me just write this out. So cotangent of theta is 1 over tangent. And so toa, it's what? Opposite over adjacent. Oops, that's adjacent. So the cotangent is going to be adjacent over opposite, but they're telling you that that's 4 over 3. So that means that, let's see, adjacent side of the, oh, that should be cosine of alpha. Sorry about that. We're talking about the reference angle. Okay, so with that said, adjacent side of the alpha has length 4. Opposite side has length 3. All right, so to determine the hypotenuse, that's what? 4 squared plus 3 squared square rooted. So, right, so this is going to be what? Square root of 16 plus 9, which is 25. So h is 5. So from here to here is 5. Okay, so yes, I know that I can plot this point and then call it A's and B's, but let's just not do it this way. Let's just straight up use the reference angle theorem. All right, so let's first go with sine of alpha. right, sine of alpha, oops, sine is opposite over the hypotenuse. All right, so the opposite side of that triangle, the angle alpha is 3, hypotenuse is 5. Okay, now let's determine what the sine of theta is going to be. So that implies that sine of theta. All right, so in quad 3, sine is negative. So in this case, we're going to have negative 3/5 is sine of theta. All right, now let's go with the cosine of alpha, the reference angle. Why do I keep doing this? All right, so cosine is what? Adjacent over hype of that triangle. So adjacent side is 4, hypotenuse is 5. All right, so that implies that cosine of theta, that's what we're looking for. Now, is cosine positive or negative in quadrant 3? It's negative. So here you're going to have negative 4/5. All right. So I think we're good to go because we got the sine and cosine. So let's derive the rest of it. So the tangent of theta is what? Sine over cosine. So we're going to have what? Positive 3/4. I don't know why I wrote the positive there, but all right. And then let's go with the cotangent. Is 1 over tangent, so which is going to be positive 4/3. And then secant is 1 over cosine, so you're going to have negative 5/4. One more. Cosecant of theta is 1 over sine, so in this case you're going to have negative 5/3. So hopefully you are kind of getting hang of it. But anyways, if you have any questions about this one, please let me know. I'll be more than happy to re-explain everything for you again.